The machine we're building now will be 250 degrees Celsius. The next machine that we'll build next year will reach 550 degrees Celsius. And that's when we'll actually have the title of hottest heat pump in the world. And that heat pump will be for other applications, especially oil and gas. There is a lot of desire to decarbonize in oil and gas because there's so much subject to PR. But not only, there is also the automotive applications, and they require the hotter machine.
Welcome back to the Decarb Connect podcast. My name is Alex Cameron, and I'm here this week with Andrei Klochko, who is the CEO and co-founder of Airthium. And we're going to be talking about decarbonisation of industrial steam and heat, and of course about Airthium's journey, as well as the stage of development that they're at. Andrei, welcome to our podcast, first of all. And could you kick off with a little bit of background, both personal and professional, on how you've come to this point in time? So how did you come to be at the helm of a disruptive tech company? And where has that all come from within you?
So it's been a long journey. So it all started many years ago. I knew I was going to do a startup for many years, basically. The first idea was in 2010. Had several ideas after that moment, and then it culminated with Airthium. We started that in 2016. Back then, it was still a technological push. So it was basically, we had an idea and we wanted to, actually I had an idea back then because at first it was just me. Then my co-founder joined me. It was a new kind of engine and wanted to find an application for it. And eventually we did. It's a new way to compress gases. It's a way that is much more efficient. Nobody has done that in a very long time. We took different approaches to it, and had we not took that path, we might have not found what we found eventually. So it was quite a big bet to go through that route. But I just knew from a very long time that I was targeted at having my own company eventually. Some people just feel that way very early on.
So does it sounds like the kind of the impetus was more you designed a technology and then it had to find its home. Would that be the case? So how long did it take to find that application in industry and its role in decarbonisation?
So it wasn't instantaneous at all. Our first incarnation of the tech used liquid metals, and it was very nice on paper, has all those advantages, and we validated so many things on this tech. But eventually it was corrosion that was the downfall of that incarnation of the tech. But because of all the things we had found on our journey, we were able to pivot technically to a different version of that technology. And then we built some technological bricks to enable the core tech of fast near isothermal compression to build an actual machine that did something. For a very long time, it was all about energy storage because we felt there was a need for this. But at the same time, we knew the market was tough to get into. Energy storage is a very tough market. So many companies have tried and failed. And the only one that really took off was lithium-ion. And that's because it had several beachhead markets, one after the other. First, it was cell phones, then it was cars, and then it became the grid. If it had gone after the grid right away, it would have never succeeded. The price point was way too high. So it's the same happened for us, and eventually we found this heat pump market. And the energy crisis that happens for now, in a way, it's challenging for a lot of companies, especially in Europe, because energy prices have skyrocketed, and some of them had to cease operating for some time until the energy prices became lower again. But the fact that energy increased in price increased the awareness of energy efficiency and decarbonization and all of that. And this is a very good signal for us. This is really what helped the company take off commercially. We haven't delivered systems yet, but we've had a lot of interest because of that. And that's where we feel that we're getting to the product market fit. We're not there yet, but we're really getting there.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. Okay, so Airthium is heat pumps, as you've said. Tell us a little bit about like which part of the kind of industrial landscape do you sit in? Who are the kind of core clients that you anticipate developing? And I know from our conversation before this that it's not that your tech is for all forms of industrial heat. It occupies a very specific temperature range. So tell us a little bit about that. So both the audience for it and the kind of the specific space that it sits in.
A heat pump is something that draws heat from somewhere and brings it somewhere else. It upgrades heat, essentially. It changes the temperature upward. This is only possible if the temperatures are reasonably close. If you go from room temperature and you try to go to 1,500 degrees Celsius, that's a very big jump. And that's something that heat pumps won't be able to do efficiently anyway. So that's why we only target heat up to about 500 degrees Celsius or 1,000 Fahrenheit. And this corresponds to paper making, cardboard, drying applications, steam in the food industry. There are some applications in the automotive sector for brazing aluminum because it's a low melting point alloy, so there is a lot of preheating involved. There is some application in steel making because of heat treatments, especially pitting, for example, which requires some kind of hot acid. This requires low temperature heat. Oil and gas industry, especially in recycling, they have a lot of need for heat in that temperature range as well. So all those companies are really actively looking to solutions to decarbonize. Many of them have had commitments. They say by this year we're gonna cut our emissions by this much, and sometimes they don't even know how to do it, at least not in a cost-effective way. And that's really what we're bringing. We are not trying to go after steel, cement, glass, or the big suspects because there is no easy way to do that. But everything else is like 15% of all industrial heat. That's 3% of worldwide CO2. So it's still a very big chunk. And the good thing is that all of that industrial heat market can be a stepping stone for us to eventually get to seasonal energy storage as a very long-term goal. And that's where we make the biggest cut to CO2 emissions worldwide because we decarbonize electricity itself. But that's a very long-term plan.
Okay, so that's a great stat for us to kind of focus on, I guess, which is 3% of worldwide CO2 is the market you're going after, effectively.
Yeah.
So I know you have just kind of given a little bit of an explanation about the nature of heat pumps, but can you tell, bearing in mind our audience is both some technology total geeks as well as the investors as well as the industrials, tell us a bit more about that. What is it about what you're doing that decarbonizes that? And based on, average CO2 output from those processes that you're targeting, what's the reduction that your technology can also deliver?
So first about heat pumps. So a heat pump is something that harvests heat. For example, you can, if you use a heat pump to heat your home, and there are a lot of heat pumps to do that today are available on the market. You basically make the outside air colder, even in the winter. So if it's -10 outside, the air is going to become -30. And the inside of your home will get warmer. So instead of +15, it will get +25, for example. And that's something that heat pumps can do. They can do it very efficiently. And to imagine how it looks like, it's like if you pick a towel and you dry away some water somewhere, and then you squeeze the towel and the water comes out. It's basically the same, but instead of a towel, we have a gas. So first we expand it, and it gets cold and cold and colder and colder. Eventually, it's so cold that it will get heat even from cold sources, so from the outside. Then you bring it inside your home and you compress it, and you compress, and the heat comes out. Even if the temperature is against it, eventually it will work. That's a very simple explanation of how it works. Then how much it saves is called the coefficient of performance. Coefficient of performance measures the ratio of the heat energy that you get divided by the electrical energy that you put in. And the missing energy is harvested from outside. So for example, a domestic heat pump will usually have a coefficient of performance of around 3. So for 1 kilowatt hour of electricity you put in, you'll get about 3 kilowatt hours of heat inside your home. So missing 2 kilowatt hours are harvested from the outside. We're not creating energy out of thin air, we're just forcing it to flow backwards. That's because electricity is a noble kind of energy and heat is not. And when you convert heat to electricity, you probably have heard that heat engines in cars, for example, are very inefficient. It's not because they lose the energy, it's because heat was a bad form of energy to start with. But the reverse transformation is possible, and that's exactly what heat pumps are doing.
Okay. So again, sort of, if I think back to the first conversation we had, I was interested that there's a particular market that you're, I guess, in competition with, in a way, at least competition for investment, which is renewables. And I wondered, do you want to just so talk a bit, because I remember being a little surprised by that. I thought you might mention some other form of, technical equipment that you're a competitor, but so why does that feel like the market of competition, and what's the comparison in terms of if someone's going to make this investment in an industrial plant, what's the benefit of going after the heat pump scenario versus, well, it may not be either or, but what's the comparison with the renewables pitch, I guess?
Yeah, so one good thing about heat pumps is they have the tendency to work a lot. They work all hours of the year, and that's a big thing. Typically, for example, a food processing company will work every day, all day, to maximize the utilization rate of all their machines. So they will have existing factories will have a gas-fired steam boiler, which will produce steam 8,000 hours a year, so almost every hour of the year. Whereas solar farm will only work about 2,000 hours per year. So when you install a solar farm, it will only work sometimes. Whereas the cost of the equipment is very similar. The cost of a solar farm is about $600 per kilowatt to install. So to build the solar farm, to build a kilowatt of solar farm, you need about $600 for very large projects. Of course, for smaller projects, it gets a lot more. For heat pumps, the cost per kilowatt of thermal energy you supply is about $300 per kilowatt. And we will probably get in the same ballpark. The cost per kilowatt that you harvest, let's say free energy, because you're harvesting heat from the ambient heat, it only works because you pay the electrical costs alongside of it. Otherwise, it wouldn't work, of course. But the cost divided by the kilowatts of ambient heat that you pull out is about $600 per kilowatt as well. The big difference is you operate 4 times more, so your amortization is 4 times shorter. And it gets even better than that because solar farms sell wholesale. They sell electricity to the grid, which doesn't pay that much to buy the electricity. But a heat pump avoids electricity consumption downstream. So it avoids the necessity to pay grid fees, taxes, all of that. So all of this cash enters into the cost saved by the heat pump. So because of that, I tend to say they are 6 times more profitable than solar farms. So they pay back a lot faster, which means they're a lot easier to deploy. That's exactly what we look for in a beachhead market. This means a lot of things. This means it will be easy to find funding to fund the machines themselves, to buy them and bring them to life. So it will not be the end user buying them. It will be financial partners supplying cash, then getting paid back by the payments from the end user, taking the risk. But eventually, because it's so profitable, they're okay taking the risk. And then we can also sell machines, even though they're manufactured in small batches. This works anyway. So when we scale up, we decrease our costs, we become more profitable. It's been profitable all along. And that's why it's a great beachhead for us, because then the same machine, what we plan to do is to have it as a cornerstone of this big seasonal energy storage system. And we have validated that by the heat pump market, which is a huge market in itself. It's $13 billion a year. Just our market, just our segment.
So you've actually touched on something there around when you talk about scaling up, one aspect of it that we hear a lot from industrials, which is, and actually it's a kind of a question or not a concern, but it was a question when I first heard it that it just hadn't occurred to me. It was an issue, which is around space, like the space requirement of different technologies when you're bringing them on or near a site. So where, if you can, it's always hard on an audio podcast to do this, but can you give a sense of like the demonstration or piloting tech that you have at the moment? What is the size and scale of that? And then if you imagine your average application, so the average client you would have in future years, and the average size of, stage of the technology, what's the scale up difference? What kind of on-site space requirement is there both now and in the future?
That's a great question, because space is often overlooked in many applications. For example, a solar farm takes a lot of space. A gigawatt takes 10 square kilometers. That's actually really huge. Sometimes people overlook the space requirements, and a solar farm takes a lot of space. For example, a gigawatt takes 10 square kilometers. That's 3 by 3 kilometers. It's huge. And typically our clients have boilers in 20 megawatt scale, which isn't that big for a gas boiler, but the solar farm required would be positively huge, especially taking into account that you have to linearize the power. So you would need 20, but probably 100 megawatts of base energy. And there is never nearly enough space close to existing factories to put that. Even new factories cannot find that much space. Now, considering other solutions, the good thing about heat pumps is they're not that much bigger than gas-fired boilers. Gas-fired boilers are very hard to beat in terms of capacity. They're kind of the most compact energy conversion systems we have for what they make. But factories have the space for what we have. We worked with a company called Airthiums, which installs heat pumps for a living in all kinds of very tough environments. And what we told them about our sizing didn't surprise them a bit. They said, "Oh, okay. No worries about this." So yes, also biofuels have the same problem. You need so much land to cultivate the raw material to make the energy you need for decarbonizing all of that. The only thing that needs some work sometimes is that you need the electrical connection to be upgraded if you electrify. But that's everywhere. That's the same for electric cars. Grids are aware of this. So yeah, it's just a constraint to take into account.
Okay. So you mentioned earlier some of those kind of the classic customer types, the types of companies that you would that you are kind of in touch with and that you are marketing this towards. When you go to them, I'm interested to what extent is the CO2 reduction the kind of number one win for them, or is it still the energy efficiency and the energy cost angle that wins? I guess the question is, which is the winning argument right now, and is it changing at all?
So it's interesting because every partner in the value chain has a different soft spot. I would say for the end user, the big thing is they made decarbonization commitments. Some of them are family-owned businesses. They really take those things seriously, and they want to make sure that they hit their goals. And for that, they don't have many other ways. And they just see our heat pump as the easiest way to get there. They look at cost, of course, and that's what drives them. But they're really scared of the CO2 as well sometimes. For example, one company told us that for them, the future cost of CO2 is estimated to be $180 per ton. Not only for burial, but just as a carbon tax, for example, in Europe. That's actually huge. To get a measure of the equivalent cost, you can divide the cost of the ton of CO2 by 5 and get what it adds to the cost of natural gas. That's a ballpark estimate. Then when you use a gas boiler, it's not 100% efficient, so it's actually more than that. And for example, 180, that gives 40, sometimes $50 per megawatt hour more on the cost of natural gas, which is very big. So they're afraid of this. They're afraid of being sitting ducks in front of changing regulation, which can swing at any moment. And that's why they want to protect. If you ask the financing companies who fund the projects, they're really after the profitability of the whole scheme. So they will say, okay, how much is the end user prepared to pay? How much is the equipment worth? How long is the payback time? How much do we need in maintenance and all of that? And also, I had some very interesting feedback at the point. I talked to a company who had a very big gas turbine to provide electricity and heat. It was a cardboard company. And they said, okay, we use electricity because we have some electrical needs and we have the steam. And I asked them, would you be willing to have a combined heat and power facility where you take the electricity and run the heat pump with it? So essentially, you burn less gas for the same amount of steam. And they said, oh, we'll never do that because that's blasphemy. They didn't say it this way, but that's how it felt. They say we don't use a carbonated source of energy to run a heat pump. It doesn't make sense from a philosophical perspective or something. And right there, they basically revealed what their idea of the cost of CO2. It's at least the profits they're not willing to make because it doesn't make sense from a CO2 perspective. And we, of course, factor that into the business model. So it really depends who you talk to, and people are really eager to decarbonize. And I was positively surprised by this.
So we talked about cost, we talked about space. When you're talking to your potential client base, are there any other kind of question marks or areas that really keep coming up about, how this would work for them on their sites?
So for most companies, the big risk is always scale up. So they see us today, which we're still a startup. We basically have one prototype. We're about to finish 5 kilowatt machines that goes to 150 degrees Celsius. And that's already a big deal. Very few heat pumps have reached that mark, and most of them are not designed to be efficient in an actual industrial setting, which is why I usually say we will be the first heat pump, first generalist heat pump to reach those temperatures. And that's already a big achievement. But many companies fail between that phase and the scale up. So of course they say, okay, we hope you scale up and we hope it works. There is always a risk. But at our stage, we have gone further than many other companies trying to do this. And that's already a great start. Other than that, it's a lot of enthusiasm that we see. People are really they have all this PR coming at them, asking them to decarbonize, and they have not that many solutions, so they're really happy to find one.
Okay, well that leads nicely then into where are you at? So you're at this early stage with a prototype in hand, more development on the way, but tell me a bit more about like what needs to happen for you in the next year, 18 months, both in terms of the work around scale up, but I guess also the financing around scale up. Like what's your journey? What has your journey been on that, and what next for you?
So we were lucky to be selected for Y Combinator back in 2017. Back then, it was on the energy storage idea because the space was very hot for energy storage, and that was the first application we had in mind because of the big impact. We had funding from very different sources, lots of angels, a few family offices, some VC checks very early on. And right now we are still fundraising. So we have a round going on this year. We have made quite good progress on that round already. And we are 12 people, thanks to all of that funding that we had before. 12 people full-time working on the project, me and my co-founder plus 10 employees. And we will recruit more people this year and next year, especially postdocs, a few more senior roles. Basically, we need to go as fast as we can to deliver on the timeline because we're not alone in the space. For now, we have a great tech. We don't know any serious competitor in our exact segment, but of course, things might change any day. So we are going as fast as we can. That's really what's in front of us now. And next year, if all goes well, we will raise the next round. And that will be to prepare for industrialization and actually delivering many systems, starting to scale up, using also the leverage of the financing partners who can take the equity of new projects, essentially enabling us to have a commodity model eventually, even though it's not a commodity, but it will work just the same.
And in engineering terms, what's the next kind of step for you?
So we are lucky to be building the first hot iteration of the machine. It's very tricky to make a machine where everything works together, and we are at that point. We are at the point where we just sent all the detailed drawings, the CAD drawings, to manufacturers so that they can make all the parts of that hot prototype. And that's a first in all those years. It was hard to bring everything together where everything passes all the tests and we can actually manufacture it. After that, we will have scale up, and we'll also have scale up in temperature. The machine we're building now will be 250 degrees Celsius. The next machine that will be built next year will reach 550 degrees Celsius. And that's when we'll actually have the title of hottest heat pump in the world. And that heat pump will be for other applications, especially oil and gas. There is a lot of desire to decarbonize in oil and gas because there's so much subject to PR. But not only, there is also the automotive applications, and they require the hotter machine. And then, of course, we'll scale up until 20 megawatts, which is the largest heat pump size that we've been asked for, especially in the food and agro industry and the paper industry. So that's a little bit of what lies ahead. The big, tough science is behind, and now it's a lot of clever engineering left. Also, some project management, being able to do as many tasks as possible in parallel to get the time to market faster. So it's all about that now.
And yeah, I guess the last question for you then, like, what's your call to action? You've got the Decarb Connect podcast at your disposal. Who do you want to hear from, or what would your kind of call to action to the market be?
Yeah, so to me, there is a much bigger dimension to what we're doing than just a profitable business endeavor. That's necessary, but that's not sufficient. To me, the big thing here is how little time we have before we make irreparable damage to many of the commons that we currently take for granted. The biggest one for me is biodiversity. Essentially, if we kill too many species now, there is no guarantee that we'll have this diversity coming back. Even bioengineering cannot guarantee that today because life is so complex. Believing we can rebuild that after the fact using just science is a bit of a wizard's dream, right? We believe we can do everything, but who knows, right? Life is so complicated. So to me, the big priority now is safeguard everything we can. So it's going to be preventing climate change, preventing the warming up of the atmosphere, the acidification of the oceans. That's, of course, the one we're fighting now. But there is also plastics. There is habitat change. Everywhere where living species are, we're changing their habitat. And it's not only about the species we see. The microscopic life is so rich, we don't even know how many species are out there. And if that biodiversity starts to die out, if the soil gets poorer and poorer, how do we know it will come back to normal and that it won't affect us or our biological beings? So essentially, to me, we need profitable business endeavors, but we need also much more environmental consciousness and action. So people have to find ways to work together. It's easier said than done, of course, and there are many ways to do this. Politics is one way, startups are another way, corporate action is also a different way. So many different ways exist and have to be explored. The end result matters, and it has to be done consciously and responsibly. To me, it means who I'm looking for personally, of course, is investors, it's new recruits, it's people who can propagate our message. I'm here for the long run. I'm here to see an impact. I'm here to have this result that when I leave this earth, we will have saved as many species as we can. We shall build huge natural reserves wherever we can. Then we actually have a shot at seeing what lies ahead for people in the next 100 to 200 years, right? People think shorter term, of course, there is AI as an existential risk, and that cannot be overlooked. But we need to tackle everything. We need to be ready to to protect our way of life in a living planet. And there is a lot to do, and we are many of the great human values are best visible when we start working together on something that matters. So I'm really eager to see how people will organize on this, and time is against us, so we have to act fast.
No, I think that's a great note to end on. And for all the investors out there, he started that by reminding us that, yes, it will take profitable businesses. Don't worry. Profitable businesses are definitely the key. But yeah, quite on the money there, I think, about the need for sort of faster action, but tied to stronger collaboration. So I really hope, Andrei, you'll come back maybe after the funding round and when you're at your next level of scale and tell us how things develop. But in the meantime, thank you so much for coming, and great to talk with you.
Thank you, Alex, for hosting me. We'll be very happy to share our progress once we have some very meaningful milestones. The next one's coming. Thank you.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform and inspire. Reach out to us today.